Okay. Let's do class 10 icse chemistry. So what should we do today? Let me see through my book. We will do let us do study of compounds. Study of compounds. We'll see how much of it is possible or not. Okay. So study of compounds is mainly divided into four: HCl, hydrochloric acid, HCl, hydrochloric acid, and then nitric acid, ammonia, and H2SO4. We'll do the first two in this one. Let me open up the page for you guys. I have to open up the page. Okay, hydrochloric acid, here it is. Hydrogen chloride. So, preparation of hydrochlor. Well, let me write down HCl. And let's write down. First part is preparation of HCl. Of HCl. So there are a few methods HCl can be prepared, and here are the follows. The first one is direct combination. So direct combination is the first one. Let me write that down. Direct combination. So in this, what happens is, in direct combination, I will okay. In direct combination, what happens here is hydrogen H2 plus Cl2 is mixed together. That is direct combination, of course, where two chemicals are directly combined and they form uh, 2HCl, which is in the gaseous state, under the condition that it is under diffused sunlight. Another method of preparation is by reaction of metallic chlorides with concentrated sulfuric acid. This is also the laboratory method, and so I'm just going to write it as lab method here. Lab method. So in laboratory method, what happens is we the main this thing rock salt, that is NaCl plus H2SO4 is under 200 degrees Celsius is used, under 200 degrees Celsius, to give NaHSO4 plus HCl, which is in gaseous state. Now there are a few other parameters, I guess. Let me check. Okay, yeah, that is it. So rock salt plus H2SO4, that is H2SO4 here is concentrated. It is important to remember. So let's talk about the reactants. So this is the formation, that is the laboratory method here. Now there are a few important things to note. Let me write down this in white. In the whole this thing, only sodium chloride is preferred. Sodium chloride is preferred because it is easily available and it is cheap. And H2SO4 is considered over concentrated HNO3 because of HNO3's volatile nature. So if that happens, it may react with hydrogen chloride. And there is another point that we have to remember here. Why concentrated? Because concentrated H2SO4, why concentrated H2SO4 is used? As it is a non-volatile, high boiling point solution, and it has a high boiling point which displaces the and does not displace the volatile hydrogen chloride from the salt. That is one thing to remember. Now about the temperature should be under 200 degrees, because if it was over 200 degrees Celsius, okay, if it was over 200 degrees Celsius, this was what this thing would have looked. H2 NaCl plus H2SO4 over 200 degrees Celsius will give you Na2SO4 plus HCl. Now Na2SO4 that is the reaction. Now there are a few main points that you have to remember here. So one of them being that Na2SO4 forms a hard crust. A hard crust and is stuck to the bottom of the test tube, which is hard to remove. And another thing you have to remember here is that another point to remember is that fuel is wasted. So excess of fuel is used and it is hence wasted. And another reason why over 200 degrees is not used is the glass apparatus may break. What would happen if the glass apparatus breaks? We wouldn't want to know. Now that is all it, and you hear the end product. We don't need to know about that, do we? Now let's talk about the purification of the HCl that we get. How do you purify the HCl? Well, to purify the HCl, for the purification, the drying agent used is agent used is H2SO4. And why is that? Because it should drying agent should only remove moisture and not and it should not react with react with HCl. That's what it means. So it should not react with HCl. Hence so the drying agent used is H2SO4. The drying agents which are not used are CaO, calcium oxide, or P2O5, because let me write down the equations for you guys. CaO plus 2HCl gives CaCl2 plus H2O. It ends up reacting, and 2P2O5 plus 2P2O5 plus 3HCl gives POCl3 plus 3HPO3. As you can see, they end up reacting with HCl, and if you have not seen something, let me point that out to you. Here H2SO4 H2SO4 is an acid, and if you have seen HCl2 is an acid, whereas CaO and P2O5 are both basic in nature because they are oxides of metals. So both of them are basic in nature. So that is one important thing that you have to remember. Now let's talk about another few stuff here. Now talking about how collection of HCl is done, let's me write that down. Collection of HCl, it is done by the downward displacement of air. Oh, sorry, not downward, it's upward displacement, because it is lighter than air. It's heavier than air. That's why it's collected by upward displacement of air. HCl is and it is not collected over water, as it is highly soluble in water. So if it is highly soluble in water, what happens is, while collecting it over water, it will dissolve in water, and you won't have your HCl gas anymore. So we have that HCl there. Let me make a small division down there, and let's continue on with the next thing. Next part of HCl. Here, I'll continue the HCl part again over here, so let me do that. Okay. So now moving on, let's talk about properties of HCl. Now this is very important. Properties of HCl is very important for you guys. And next we'll move on to hydrochloric acid, and this is pretty easy. HCl is pretty easy, except the fact that you have to remember so many of the equations given. Now let's talk about physical properties of HCl. Now under properties we'll talk about physical properties first, and then chemical properties of HCl. Let's talk about physical properties. Now so HCl is colorless, odorless, pungent, choking odor, and it is slight solid state, which is not required, and it is heavier than air. You don't have to remember how many times or how heavy than air it is, but it is heavier than air. And it is highly soluble in water, as we have seen in the previous thing for collection of HCl. Something that might come as a question will be this: HCl gas fumes in moisture. Now for this the answer is due to its high solubility. You cut it something. Okay. Due to its high solubility, comma, HCl gas fumes in moisture and it forms a mist of droplets of HCl acid. Now let's talk about another part. There are two experiments, which is the to show dry HCl gas is heavier than air, and there is the fountain experiment. I'll show you guys by drawing it. Now this comes under the physical properties, so I'll draw it down here. Let me draw that. So let me use this white pen color to draw a box. Inside the box, okay, and maybe a small jar there, and let's draw a candle. Candle. Okay. And there are a few flames. Now something to remember that is this tube here will contain dry HCl. This is normal air, and once the dry HCl air, once the I'll do that again. Try HCl and air. Now when you bring this thing closer, let me draw arrow marks to show that when you bring this closer, all the dry HCl or the gas inside will fall to the lower part here, and all the air will be on the top, and hence the due to its density, comma, HCl will settle down and air will rise up, and due to the lack of O2, the flame will be put off. So that is the explanation here. Now the other experiment that we have is the fountain experiment. The fountain experiment shows that HCl gas is acidic in nature and highly soluble, which is pretty much important to remember. So let's do this. Now this tube type of thingy is connected invertedly, and there's a dropper and a jet tube here, to which this is it is in a beaker, where it is connected in a beaker, and it is filled with a blue fluid. This blue fluid is called the blue litmus solution. Now the dropper contains water, and on top we have the HCl gas. I'll write it down here. When the dropper is squeezed, comma, water is forced into the inverted flask, where it is absorbed by HCl. This creates a vacuum, causing the litmus solution to flow up. When the solution comes in contact with HCl, it turns into a red fountain. So this is the fountain experiment. Both the experiments are done, And now let's move ahead to the chemical properties of HCl. Chemical properties of HCl. Now, a few chemical properties. There are a few chemical properties, and we'll move ahead with the chemical properties of preparation chemical properties of hydrochloric acid. Test for hydrochloric acid, uses of hydrochloric acid. First, let's talk about chemical properties of hydrogen chloride gas. So it is a non-combustible gas. It doesn't support combustion. Now indicators, action of indicators is important, so let me write that down. Indicators. Let me write it down as fast as I can. Okay. Litmus, it turns blue to red. Methyl orange, orange, it turns orange to pink. And phenolphthalein turns colorless. It stays colorless throughout. Now if it is alkaline, phenolphthalein alkaline, if it is phenolphthalein alkaline, it turns pink to colorless. Thermal dissociation, so it dissociates okay, let me write down thermal dissociation. So 2HCl, it is a reversible reaction under 5000 degrees Celsius will give you H2 plus Cl2. This is something to remember. And a few reactions to remember are so the first reaction is with ammonia, so NH3 plus HCl will give you NH4Cl, and if you didn't know, this gives out a white fumes. This is one of the tests for ammonia, and you can also test it by using it's a test for ammonia, and you can also use it for testing HCl2. Now reaction of the hydrochloride gas with a few metals, so let us say Zn, Mg and Fe. Zn plus 2HCl will give you ZnCl2 plus H2. It liberates hydrogen. Again, 2HCl will give you MgCl2 plus H2. Now Fe has two variables, so usually a lower variable is taken, and it forms two chlorides, so Fe2Cl FeCl3 and FeCl2, but usually it's taken the lower chloride is formed, so FeCl2 plus H2. that is it for hydrogen chloride gas. Now let's move on to, let me draw the lines out first. Now let's next we'll be moving on to hydrogen chloride acid, hydrochloric acid, I mean hydrogen chloride acid. Usually preparation is through a special funnel arrangement. Let me draw the diagram out for you. So there are a few ways you can do this. Let me show it to you step by step. Now here is a okay. So usually hydrochloric acid is formed by the direct addition of HCl2 water. Now there is a box, HCl is added into it. Okay. Usually what happens is when since HCl is dissolvable in water, let me do two cases here. So that that and that and that and that. So this is the final arrangement. So let's take here the water. Now water is in all of these three jars. Okay. Usually when HCl gas is, if you directly pour HCl gas, it will come all the way down and it will soon start mixing with water here. But the reaction will occur so fast that almost a back suction starts creating itself, and therefore all the water will start entering into the test tube here, which might damage the apparatus. So instead what we have done here is there's a special funnel arrangement used. A special funnel arrangement is used where with and when HCl is passed through it, it does not happen. It does not suck in the water as fast as it does because a small air gap will be formed which will prevent that from happening. So in this case back suction happens, whereas in the other two cases it doesn't happen. Once that is done, this is how you create. So let me write down the that's how you create hydrochloric acid. And let's talk about the properties. Now again we'll start off with physical properties, which is always less so comparative. This is very it is similar to HCl, so let's look at it. It is a colorless and it has a slightly pungent odor. So model. And these are the 2 points. So HCl in water forms a constant boiling mixture which when both HCl and H2O are in equal quantities. Therefore, you cannot have. Therefore, you Therefore, HCl cannot be concentrated beyond a certain concentration point, because after a certain point, a poly mixture evolves and it starts turning into vapors. Now, moving on to the chemical properties. Let's talk about the chemical properties. The first property you have to remember is that it's acidic property. So, acidic property of HCl. So, it is a monobasic acid, basic in nature because it dissociates into to produce 1 H plus ion per molecule, and its acidic nature. This is acidic nature is due to the presence of H plus ions, causes it to have acidic property. And okay. So if you I'll show you a few patterns which you have to remember, like the formula. So if an acid plus an active metal react, they give salt and hydrogen. Now since our chapter is about HCl, let's take the acid as HCl plus an active metal, like anything, like let's take Zn. So 2HCl plus Zn gives you ZnCl2 plus H2. The next property is acid plus base will give you salt and water. This is very common. So now again HCl plus a base CaOH twice will give you CaCl2 plus 2H2O. Now another one is acid plus I'll write it as CO3 carbonates and bicarbonates will give you salt plus water plus CO2. So an example here is, again we'll take HCl plus sodium carbonate or sodium bicarbonate, and NaHCO3 will give you a salt which is NaCl plus H2O plus CO2. The next one is acid plus sulfide and sulfides and bisulfite. So SO3 slash HSO3 will give you salt plus water plus sulfur dioxide, SO2. An example is HCl plus Mg2SO3 and MgSO3 will give you salt is MgCl2 plus 2H2O plus SO2. The next and the last one is acid plus sulfide will give you salt and H2S. So if you are going to write down HCl plus sulfide, let's say ZnS will give you ZnCl2 plus H2S. If you were to balance that, these are the few things you gotta remember. I am gonna do that so that it's highlighted. Okay, moving on. There are a few other reactions that you have to remember. I'm gonna just write those down here. Let me write this down. AgNO3 plus HCl gives AgCl plus HNO3. AgCl is a precipitate which is a white precipitate. And CuS, which is originally black, plus 2HCl will give you CuCl2, which is blue, plus H2S. Now another one is thiosulfate. This is for reference, but Na2S2. Oh, there's another one. Wait. So PbNO3 whole 2 plus 2HCl gives you PbCl2 plus 2HNO3. PbCl is white and it is soluble in warm water but insoluble in cold water. Now the thiosulfate one, Na2S2O3 plus 2HCl gives 2NaCl plus SO2 plus S, which is yellow, plus H2O. This is not exactly required, but it is better to go through it. Now moving ahead, there is the second property, which is its oxidizing property. First we learned about the acidic property. Now we talk about the oxidizing property. So oxidizing, oxidizing property of HCl. So it is a powerful oxidizing agent. And wait, this is wrong. Wait. Oof, I messed it up. Okay, it's the reaction with oxidizing agents. So let's learn the reaction. So powerful oxidizing agents. So powerful oxidizing agents. When it reacts with powerful oxidizing agents, example is MnO2, PbO2, KMnO4, K2Cr2O7, K2Cr2O7. So what happens is oxidizing agent plus HCl will give salt plus H2O plus chlorine. Now let me give you all of this thing which I have given above. Let's start off with MnO2, PbO2. These are technically same because the valencies are all the same. 4HCl will give you on heat MnCl2 or PbCl2 respectively, 2H2O and Cl2, and the next is Pb3O4 plus 8HCl on heat gives PbCl2 plus 4H2O plus Cl2. The next one is KMNO4, KMNO4, this is capital M, 2KMNO4 plus 16HCl will on heat will give you 2KCl plus 2MnCl2 plus 8H2O plus 5Cl2. 2K2Cr2O7 plus 14HCl will on heat will give you 2KCl plus 2Cr2 CrCl3 plus 7H2O plus 3Cl2. Something you have to also remember is HNO3 plus HCl. Both are concentrated, or these both on reaction will give you a salt, which is NO. Which will give you NOCl, nitrosyl chloride, plus 2H2O and plus 2Cl. This is nascent chlorine. And this mixture is called aqua regia. And aqua regia forms this 2Cl, right? So Cl is both the Cl's. It is used to dissolve noble metals, example gold and platinum. So plus Au plus Pt will give you this 3Cl. This is 4. Each will give you AuCl3, PtCl4. So it is used to nascent chlorine is technically used to dissolve noble metals which are otherwise not dissolvable. Dissolvable in other acids. Yeah. Moving on, let's talk about tests and then a few uses and we are done. Tests. Now the tests are as follows. We can do a glass rod dipped in this thing, which is NH3 plus HCl will give you NH4Cl, and this is dense white fumes. Another thing is addition of AgNO3 plus HCl will give you AgCl, which is white precipitate, and HNO3. Addition of this can also help you distinguish between HNO3 and HCl. Now this is because HNO3 and AgNO3 have the same anion, and so it won't react with each other. Another property is, another test you can use is action of heat on manganese. Okay, so MnO2 plus 4HCl, and you provide heat to this. On doing so, you get MnCl2 plus 2H2O plus Cl2. Now a few uses of HCl are: it is used for dyes, manufacturing of dyes, drugs, and and other uses are like pickling of metals, and then preparation of aqua regia. And once again, aqua regia is used to dissolve the noble metals which otherwise will not be able to be dissolved by any other acid. And that is it for the first part. This is all of it. I have not used. I'm gonna mark this so it's 4, 4, 18 and 4, 4, 8, 16 and 14. These are a few important ones. And this is important too. This is pretty. Yeah. That's about it.